Let's say we have our same weightless bridge, but instead of our 100 pounds hanging from the center of it, we move it over to here. How will that affect the forces on our bridge supports? Obviously, this one will have an easier lift, and this one will have more to lift. Okay, let's look at all the forces times their distances about a certain point. Let's let this be that certain point for our first calculation. Let's call the force that the left bridge support X, and we'll call the right bridge support's force Y. So let's look at all the forces trying to turn this bridge either counterclockwise or clockwise about this point. Well, we have this bridge support is pushing right at that point, so that would be X times 0 distance, because it's not far away from it like this 100-pound weight is. It's right at it. So in other words, it doesn't really count in the equation. So we have this 100 pounds times this distance. We could call that 1 arbitrarily. That'd be 2, that'd be 3. This would be 1/2 from here to here, because we've established that this distance down there is equal to this distance and equal to this distance, so this would be twice this. So let's call this 1, 2, 3, and since it's clockwise, we'll call it positive. So let's say plus 100 times 3. Okay, and now we have the right bridge support. It's pushing up, trying to turn this bridge counterclockwise, and its distance is 1, 2, 3, 4. So let's say minus y times 4. It all has to add up to 0, just like that wrench we looked at in the last part. One guy trying to turn it one way and the other guy trying to turn it the other way. If it's not moving, the guy pushing closer to the bolt has to push harder. Well, let's look at our equation. X times 0 is 0, so we have 300 minus 4y equals 0. Let's add 4y to each side of the equation. 300 minus 4y plus 4y leaves us with just our 300 equals 4y. Let's divide each side of the equation by 4. We have 75 equals y. We know that x plus y equals 100. So y would be 75, x would be 25. We can work this problem out another way. Instead of looking at all the forces times their distances from this point, let's look at all the forces times their distances from this point. Well, we have x pushing up here, and it's 1, 2, 3, 4. 4 whatever's, 4 feet, 4 meters, 4 inches, we don't care. As long as we know how this proportion, we know that is twice as much as that. Okay, so x times 4 is the force times the distance about this point. So let's write 4x. It's going clockwise, we'll call it positive. Okay, here's 100 pounds trying to pull this bridge counterclockwise about this point. So let's say minus 100 times 1, because it's 1 from there to there. Okay, now the right bridge support is pushing right through that point, so plus y times 0, which is 0, equals 0. Okay, so we have 4x minus 100 equals 0. Add 100 to each side and we have 4x equals 100. Divide each side by 4 and we have x equals 25. Same answer we got last time. X 25, y 75, because x plus y has to add up to what our weight is. Remember, our bridge is weightless. Only our 100 pounds has weight. We've looked at all the forces times their distances about this point. We've looked at all the forces times their distances about this point. Let's try this point. Okay, we have X trying to turn this bridge clockwise about this point, and its distance from there, let's call it 3. 1, 2, 3. X times 3 clockwise. Okay, we have 100 pounds pulling right through that point, so its force vector is 0 distance away from that point. So we can call it plus 100 times 0, or we could say minus 100 times 0. It doesn't really matter. Anything times 0 is 0. Okay, now we have Y, the right bridge support, trying to rotate the bridge counterclockwise about this point. So we'll call it a minus. So minus Y times its distance, which is 1, all adds up to 0. So 3x plus 100 times 0, which is 0, minus y equals 0. 3x equals y. But we know that x plus y equals 100, so x is going to equal 100 minus y. So let's say 3 times 100 minus y equals y. So 300 minus 3y equals y. Add 3y to each side of the equation. 300 equals 4y. Divide each side by 4 and you have the same old answer. 75 equals y. We can even figure all of our forces times their distances about this point if we wish and still find our answer. Okay, we can say x times 1, 2, 3 and a half. We're not measuring from that point to that point. We're measuring from that point to a line going under that point. It's kind of like if you have a nut here and a wrench on it. There's the other end of the wrench. You slide it over so we can see it. And you drill your hole there and you tie a string to it and you pull it this way. Well, it's not this distance that you multiply your force times, it's this distance, because your rope is a little closer to the nut here than that hole is. So we're not so concerned about this distance from here to there, even though it's almost the same. We're concerned about our distance from our force vector to this point. Our force vector goes straight up, so it would be a distance from there to this point, which is 3.5 if we're going to call these 1 between there. Remember that was half of that, and that is half of that. May not look like it, but it is. We've established that earlier. So that's 1, 2, 3.5. So let's say x times 3.5 is its force times distance about this point. So 3.5x. It's going clockwise. We'll call it positive. Okay, here's 100 pounds trying to pull this counterclockwise about this point, and it's 1/2 away from it. So since it's counterclockwise, we'll call it minus 100 times 1/2. Okay, now this y force is also trying to turn it counterclockwise. So let's call it minus y times 1/2, because it's 1/2 from here to here. This force vector is right up here. The perpendicular distance to it is 1/2. We're arbitrarily calling that 1, so that's 1/2. Okay, here, and that's all balances out, so it equals 0. Okay, so 3.5x, 3.5x minus 50 minus 1/2 y equals 0. So we know that x plus y is 100, so x is equal to 100 minus y. So let's just call this x 100 minus y. 3.5 times 100 minus y minus our 50 minus 0.5y equals 0. Okay, 3.5 times 100 is 350 minus 3.5y minus 50 minus 0.5y equals 0. Okay, 350 minus 50 is 300. Minus 3.5y minus 1/2 y is minus 4y equals 0. Let's add 4y to each side of this equation. That gives us 300 equals 4y. Let's divide each side by 4 and we have the same whole answer. 75 equals y. And x plus y equals 100, so x is 25 once again. No matter which point we pick on this structure, all the forces, the outside forces acting on this structure, the left and right bridge supports and this weight hanging from it, those forces times their distances from any given point on this structure have to balance out. They have to add up to 0.